Hi, let us solve this question on matrices. We are given the matrix k plus 5, 7, 2k, and we are told that it is singular and asked to find the possible values of the constant k. Now, let's first of all handle the notion of singular matrices. If we are given a matrix M and we are told that it is singular, this therefore means that that matrix does not have an inverse. The inverse does not exist. If the inverse does not exist, it also means that the determinant of that matrix must be 0, because, look at it, the inverse of a matrix is given as 1 all over its determinant times the adjoint of that matrix. So if the determinant is 0, it therefore means that we'll be dividing the adjoint of that matrix by 0, and dividing by 0 is impossible in mathematics. It therefore means that if this matrix here is singular, then we expect that its determinant must be 0. Now, with that notion in our back mind, we use that notion now to be able to calculate the values of k. So the matrix k plus 5, 2, 7, k is singular. Therefore, the determinant must be 0. If that is true, all right, how do we evaluate the determinant? Product of elements of the leading diagonal. This is the leading diagonal. So we have k into k plus 5 minus product of elements of the alternate diagonal, 7 multiplied to 2. We have that result as 0. Opening out, we have k squared plus 5k minus 14 is equal to 0. We end up with a quadratic in terms of k. Okay, so we have to solve this quadratic. So using the factorization method, we look for two factors of negative 14 whose sum is positive 5. The only two factors will be positive 7 and negative 2. And so this expression here factorizes it to k plus 7, k minus 2 is equal to 0. All right, the product of two expressions giving us 0 means either this first one is 0. If that is true, then k is negative 7. Or the second one is 0. And if that is true, then k is 2. So these are the two possible values of the constant k for which this metric is singular.